Hey, welcome back. This is the second part of greatest common factor, or GCF. Now, in the previous videos, we broke down numbers to figure out what the greatest common factors are. Today, I'm going to introduce variables, which are letters, and also I'm going to still use numbers. So for my first example, I'm going to use m to the fifth power, m to the fourth power, and finally, m to the third power. Now, I'm asking what's the greatest common factor. Well, the only thing I can see is an m, so I know they have m in common. But the question is, how many m's do we have? Now, some of us already can picture this, but I like giving a visual explanation with this. What this 5 means is I've got 5 m's. What this 4 means, I've got 4 m's, m to the fourth. And the 3 means I've got 3. So let's start over here. I've got an m, an m, an m. I've got a second m, second m, second m. Then I've got a third m, a third m, and then I'm finished with my m. So when I'm finished of having them in common, that means that's my greatest common factor. Now, when I have 3 m's in common and we're multiplying those together, remember m has a 1 power. So when we multiply exponents, this would be, you would add them, 1 plus 1 plus 1 would give 3. So my greatest common factor would be 3. Now 3, if you're looking at any of these exponents, it's usually, every time it works, you look at the smallest exponent or the least, that gives you your greatest common factor. But I'm going to prove this once again on my second example. Let's use a different variable. Let's use n7, n3, n5. Same thing. So I've got 1, 2, 3, 4, 5, 6, 7 n's. I've got 3 n's, and into the fifth, I've got 1, 2, 3, 4, 5. So let's start seeing what the answer is. N, they've all got 1 n in common. Let's see the second n. They all have 2. And the last one, let's take a look at this. Now, the n to the 3, into the third power is out. So I know that I'm finished. So my greatest common factor would be n. If you count up what they have in common, there are 3, so it's n to the third power. My next example, what I'm going to do is I'm going to kind of put a combination of, I'm going to put 125 n to the fifth, and then 25 n squared. Now, what numbers go in to make 125? Well, since you've got a 5 here at your last digit, I know it can be 5. If you divide that into, you get 25. And notice something. I've got a 25 here, and my answer right here is 25. So really, I've already found out what my number is. My number is 25. So now we can look at, so some of us are thinking right now, okay, the answer is 25 n squared because that's the smallest exponent. To prove it, I'm still going to go over here and say, okay, that's 1, 2, 3, 4, 5 n's. This is 2 n's. Then if I circle my n's, 1 n, 1 n, 2 n's, 2 n's, then my n squared I don't have anymore. How many do I have? 2. That's why it's n squared. Now, the purpose of greatest common factor leads us into the factoring itself. And for this, I'm going to use 7x plus 28. So what we're looking at is this is two terms. Your first term is 7x. Your second term is 28. So I'm thinking to myself, what do they have in common? Well, 7 can be broken down to 1 times 7. 28, I'm looking at the 7. I know that it's 4 times 7. So that means my greatest common factor would be the 7. So if I'm asking what the greatest common factor is, it would be 7. But let's factor the 7 out of this equation. So that means if I take, I'm going to rewrite my problem, 7x plus 28. So that means if I pull the 7 out, that's my greatest common factors on the outside. What is left is this. If I pull out a 7, I still have my x. And then if I pull out my 7 from 28, look what I have right here. I have a 4. And since my sign is plus, it's plus. It's 7, and then parentheses x plus 4. So if I ask you to find the greatest common factor and also to factor this problem, the greatest common factor would be 7. It's on the outside of the parentheses. And the whole answer is how you factor. So this is my factor. Factoring it out. Let's look at another one. 8x squared minus 80x. As we're getting the hang of this, I'm looking at my 8. 8 can go into 80. So that's like 1 times 8, and that's 8 times 10. So right off the bat, I know I've got an 8 in common. But now look at my x. I've got 2x. I've just got the lone x. That means I just have 1x in common. So my greatest common factor is 8x. So if I factor 8 out of this 8, you're left with 1, so you don't need it. But if I factor an x out of this x squared, look what I have right here. I just have an x. This is a minus. Now watch this. If I pull an 8 out of the 80, I have this 10 left over. And I don't have any x left over. So this right here, the 8x is my greatest common factor. And the overall 8x in red, in parentheses, x minus 10 is my factor. What about if I'm going to throw a little bit more into this? Let's say I have 6x5y minus 12x3y squared plus 18xy to the fourth. Now, I'm going to look at this to make this a little bit easier, is finding like the greatest common factor and the factor itself. The greatest common factor will be always outside of the parentheses. So let's take a look at this. 6. 6 goes into 12 and it goes into 18. So this means 6 is part of my greatest common factor. Now let me look at my x's right here. I'm looking at the one with the least exponent. And this is an understood one. It's x to the first. So that is my least one. So it's going to be 6x. And then I'm going to look at my y's. And notice with my y's, this one is a 1 as well. So it's 6x. Now, if I pull 6 out from here, I'm left with 1. So I don't have to worry about that. But if I pull 1x from my x to the fifth, I get x to the fourth. If I pull my y out, I'm left with nothing, so it's just x to the fourth. My symbol is a minus. How many times does 6 go into 12 right here? 2 times. And then x. I pull 1x from x to the third, gives me x squared. I pull a y from a y squared, and I get a y. Now, how many times does 6 go into this 18? 3 times. So that's going to be plus because of the positive sign. So 6 goes into 18 3 times. I've got an x. I'm pulling an x out. I don't need anything there. I'm pulling one y out of my y4. That leaves me y3. So the red is my factor and my 6xy is my greatest common factor. Now some of us will be introduced to a problem like this. And you all have to pay attention to this because they're trying to confuse you all to make this look a little different than what we have been. So I want you to look at this. Look at the parentheses right here. The n to the third minus 7. That's what they have in common. So I'm going to put that in parentheses. I'm going to just leave it in parentheses. Now look what's left over. An m and a minus 2. Now the m and the minus 2, you cannot factor anything out of it. So this would be my answer. Now, another question I always get asked is, does it matter the order? I mean, technically, no. I mean, this could also be written as m minus 2, n3 minus 7. And finally, now later on I will end up putting more examples about grouping, but this is just a simple version about grouping. What I'm going to do is I'm going to separate the first 2 and the second 2 terms by a big line right here. And I'm looking at the left. Forget about the right part of it. I'm looking at my left part. What do they have in common? Well, they have an x squared in common. They don't have a number in common. So what I'm going to do is I'm going to pull out the x squared from x3 and I get x. I've got my plus symbol. And then I'm pulling out my x squared, which I am left with a 6. Now, since both of these have a plus symbol, I'm going to put plus. Then I'm going to look at, can 7 go into 42? And it can. So I'm going to pull out the 7. They do not have an x in common, so I'm finished. So you pull out a 7 from 7x, you get x. Pull out a 7 from 42 and you get 6. Now notice something. Look in the parentheses. The parentheses, they have x plus 6 in common, but what is left is x squared plus 7. Now, this concludes my greatest common factor part 2, which leads into my next set of videos about factoring quadratics. Thank you for listening.